I want to get you used to working with more than one function at a time, and mostly the notation involved in doing that. Consider these two functions. F of x, which equals x plus 4, and g of x, which takes a value, multiplies it by 5, and then subtracts 2. Now please note right away that not everybody writes in different colors. That's why we have to name functions with different letters. F of x, g of x, c of x. Sometimes the letter actually means something, like a cost function would be c of x, or various other things. But for the most part, you can use any letter. Now, if we take these two functions, f of x and g of x, guess what f plus g of x equals? Probably it's going to be just what you think it is, by the way. F plus g of x equals f of x plus g of x, which means x plus 4, that's f of x, plus 5x minus 2. So f plus g of x is going to equal, adding like terms, 6x plus 2.
No way.
That's simple, isn't it? Now that's the general formula for f plus g of x. Kind of weird notation, isn't it? How about finding a value at a specific point? For instance, f plus g of 3.
I want details, and I want them right now.
Well, that's a specific point, so it's going to give us a specific answer, not just a formula, you see. That's going to be f of 3 plus g of 3. Now, f of 3 means put 3 into the function f, or add 4 to 3. G of 3 means input 3 into the function g, which is going to be 5 times 3 minus 2. And since we put in a specific value, you can see now that we can get out a specific value. 3 plus 4 is 7, and 5 times 3 minus 2 is 13, so f plus g of 3 actually equals 20.
Well, ooh-la-dee-da.
That's how you find it at a specific value.
Please come again.
Now let's take the same two functions and predict what f minus g of x would be. F minus g of x would simply be f of x minus g of x, or x plus 4 minus, now be careful, we have to subtract the whole g of x. We have to subtract all of f of 5x minus 2.
Warning, warning, warning.
Probably you want to use parentheses here, because when we subtract a negative 2, something crazy is going to happen, isn't it? X minus 5x is negative 4x. 4 minus a negative 2 is a positive 6. So be careful when you subtract functions. You probably should use parentheses all the time. They could never hurt. And that's your answer. Another thing to remember about doing subtraction,
Are you pondering what I'm pondering?
is actually, I'm going to show you that order does count. If we flip it around, g minus f of x is going to equal g of x minus f of x. And we're still going to want to use our parentheses. We'll have g of x, 5x minus 2, and we want to subtract the x plus 4.
Is that your final answer?
Well, let's simplify here. 5x minus 1x is 4x, and negative 2 minus 4, be careful, your answer should be 4x minus 6.
Wait a minute.
Yep, that's what it should be. So you get different answers when you go g minus f of x than when you go f minus g of x. So be careful.
How about little fires, Scarecrow?
How about multiplying functions?
Take off, eh?
What do you think f times g of x would equal? Well, no big mystery here. It's going to equal f of x times g of x. Here's where you're really going to need parentheses, though. F of x is x plus 4, and g of x is 5x minus 2. Now, to multiply those two expressions, you really need parentheses, don't you? X times 5x is 5x squared. X times negative 2 is negative 2x. This is like FOIL, isn't it? 4 times 5x is 20x, and 4 times minus 2 is negative 8. And we may want to add like terms here if we can. And the answer is going to be 5x squared plus 18x minus 8.
I'm dangerous. I'm very, very dangerous.
It's not that hard, is it? You see, this is nothing that we haven't done before. We're just using different notation to represent it. Function notation. Now,
I want details, and I want them right now.
let's do the same thing at a specific value or a specific point. Let's figure out what f times g of negative 2 would be. Well, that's going to be f of negative 2 times g of negative 2. Probably easiest to find the specific points first. F of negative 2 means plug negative 2 into the function f. And then we'll multiply that times g of negative 2, which means plug negative 2 into the function g. Now let's see what each of them equals first. Of course, you have to do what's in parentheses first. We've been doing that for a long time. Negative 2 plus 4 is 2. And we'll multiply that times 5 times negative 2 minus 2, or negative 12. And I'm thinking this is all going to equal negative 24. Notice that we put in a specific value, and we got out a specific value. And there it is. Now we've done addition, subtraction, and multiplication. Guess what we're going to do next?
I have a feeling some bad stuff is about to go down.
It's going to be division. And division can create all new problems. What would f over g, or f divided by g of x be? Well, quite simply, it's going to be f of x over g of x. Recall that a fraction means top divided by bottom. So all we really have to do is say x plus 4 over 5x minus 2. Now there's nothing to be simplified here, so basically that's your answer.
Warning, warning, warning.
However, whenever you have a fraction with a function, you're going to have to limit or find out what it takes to make the bottom be 0, because in a fraction, remember, the bottom can't be 0. And I see in the bottom, if I set it equal to 0 when solved for x, 2/5 would make the denominator equal 0. So my domain would be anything but 2/5. Okay, don't forget with division, you have to watch for that denominator.
Don't make me angry. You wouldn't like me when I'm angry.
So there's your domain for this function, x such that x does not equal 2/5. So, in summary, f plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. And order counts, okay? F times g of x is simply f of x times g of x. And f divided by g of x, or f over g of x, is simply f of x over g of x. And
Don't make me angry. You wouldn't like me when I'm angry.
make sure that you watch out that the denominator never equals 0. Okay?
The great Oz has spoken.
Go try the homework. Practice with this notation.